Today we're going to be solving log and exponential real-world application problems. So moving on to some real-world examples. You deposit $250 into an account that pays 4.5% compounded quarterly. Determine how long it will take for the account to contain at least $500. If you can recall, it talks about something being compounded quarterly. There was a formula that we worked with not too long ago. It's our compound interest formula. It was A equals P times 1 plus R divided by N to the NT power. So the first thing I'm going to do is go through the word problem and underline important parts. So you deposit $250. This would be our initial deposit, so that would be our P, into an account that pays 4.5%. Now that's a percent. Remember, you need to turn that into a decimal. So you can move this decimal to the left 2 places, giving us 0.045. Compounded quarterly. The word compounded is the big giveaway that you're going to use. That's our N. Quarterly means how often it occurs within 1 year. So quarterly means 4. So our N will equal 4. Determine how long. So obviously how long is what we're trying to find. We are looking to find T, the amount of time it's going to take our account to equal or be at least $500. So this 500 would be our A. I'm going to now go ahead and plug in everything in my formula and write it all down. So we know we have A was 500. So 500 equals our P was 250. So 250, open parentheses, 1 plus our rate is 0.045 divided by our N value, which we decided was 4. Close parentheses to the 4 for N times our T, which we do not know. That's what we're trying to solve for. Okay, so to get the T by itself, we need to divide both sides by 250. And when we do that, the 250s cancel. 500 over 250 gives us 2. So we have 2 equals parentheses 1 plus 0.045 over 4. Close parentheses to the 4t power. Now when we do this, I do a couple of different ways sometimes, but if you can plug in what's in the parentheses into your calculator and it will give you not too long of a decimal, then I say go ahead and simplify it further. And in this case, it does give us some decent decimal. So we have 2 equals parentheses 1.01125. Close parentheses to the 4t power. Now that parentheses is now your base. And so now we're going to have to log base both sides. So we're going to log base 1.01125 on both sides because we want those to cancel. So I'm going to continue writing over to the side a little bit so I have more room. So the left side, we're going to have log base 1.01125 of 2 equals the log base and the base will cancel, and that's going to leave us with 4t. From here, you still need to get t by itself, so you're going to divide both sides by 4, and that's going to leave us with t equals log base 1.01125 of 2 all over 4. Then plug that information into your calculator and get the value once you hit enter, and that will be our approximate amount of time. So T will be approximately 15.489. Let's simplify that to approximately 15.5 years for our money to double. Here we are with our last real-world log problem. So it says the difference between the apparent magnitude or the brightness is lowercase m of a star and its absolute magnitude, uppercase M or capital M, is given by the formula lowercase m minus capital M equals 5 times the log of d divided by 10, where d is the distance of the star from the Earth, measured in parsecs. The star Antares has an apparent magnitude, And up here it mentions that apparent magnitude is the lowercase m. So we know that this is m is going to equal 1.0, and it has an absolute magnitude. An absolute magnitude is mentioned up here. It says it's represented by the capital M. So that will be our uppercase M is negative 5.3. Find the distance. So this is what we're looking for. We're looking to find D of Antares from Earth. And it says round our answer to the nearest parsecs. So let's plug in our information that we're given and solve for the unknown. So our lowercase m we said was 1.0 minus our uppercase m, or our capital M, which is negative 5.3, equals 5 times the log of d, which is distance, we don't know what that is, divided by 10, close parentheses. So if we take a look at this, we're going to simplify where we can. It looks like on the left side we can do a little bit of simplifying. So we have 1 minus a negative 5.3, which is actually 1 plus 5.3, which gives us 6.3, because a minus a negative is a plus, equals 5 times the log of d divided by 10. Now, again, we're trying to isolate the log. So that means now we're going to divide both sides by 5. The 5s will cancel, and that gives us 6.3 divided by 5. And that's going to give us 1.26. So 1.26 equals the log of d over 10. Now, we need to get rid of this log. The only way to get rid of the log is to exponentiate both sides by the base of the log. Our base of the log is not written, but it's understood to be a 10. So we're going to exponentiate using 10 on both sides. So now we have the 10 and log base 10 cancel, giving us 10 to the 1.26 power equals d divided by 10. I'm going to go over to the sides. We have a little bit more room to work and rewrite our problem. So we now have 10 to the 1.26 equals d over 10. I'm going to go ahead and simplify the left side. We have 10 to the 1.26. I'm plugging that in the calculator. It's going to be approximately, I'm going to go ahead and round to the nearest thousandth. So we have 18.197 equals d divided by 10. Here we can multiply both sides by the denominator, and that will give us d by itself. So d equals 10 times our 18.197, which would give us 181.97. Our directions say to round to the nearest parsecs. We're going to say that distance is approximately 182 parsecs from Earth.